Example 1, sections f through n. So we're given the graph of function f, and we're going to use this graph to answer the following questions about it. Part F. For what numbers x is f of x less than 0? So we're looking for x values here. Always pay attention to specifically what they're asking for. Math is very literal and specific, so they're telling us we want x values as our answer here. We want the x values when the f of x values, or the y values, are less than 0. Well, on any graph, y values are less than 0 when you go below the x-axis. So we just want to name the x values of any portions where this graph falls below the x-axis. So if you want to make yourself a note here, remind yourself that you're looking for where the graph goes below the x-axis. So you might want to kind of cover your paper up, cover up anything above the x-axis, and then you can see that's just this portion here, this little dip where it goes below. So you want to name the boundaries of this dip. So we can say it starts to dip just past 0. So 0 is our left boundary. We're always going left to right in math. We continue all the way until we hit 4 when we actually hit the x-axis again. So we want everything from 0 to 4. And using interval notation, I'm going to do parenthesis 0, comma 4. Because this inequality is a strict less than, it doesn't have the equals on it, that's how I know to put parentheses around here. So it's asking for where it's strictly below the x-axis. Well, it hits the x-axis at 0 and 4, so you wouldn't want to put brackets on the 0 or the 4. Part G. What is the domain of f? So to refresh, remember the domain is all the set of x values that this graph would span. And we always want to go in increasing order, which would be left to right. So we want the x values, and if you want to write yourself a note here, we want the x values always going in order left to right. So you want the left and right boundaries of this graph. So we're going to start at the leftmost point of the graph, and we can see that point's -4 too. So our smallest x value is -4. So we're going to start at -4. We're continuing along. This graph is continuous. It continues all the way until we hit the x value of 6. So we know our graph is going to start at -4, and I'm going to put a bracket because I do include -4, and it goes all the way to 6 continuously, and it's including 6. I put brackets here because -4 and 6, those are included x values. If they were open circles, then we would know to put a parenthesis on each of those, but they're filled in circles. They are valid parts of the graph, so we include brackets. Okay, part H, we want the range of the graph. So now we want the set of all the y values that this graph spans. So if you want to make yourself a note, this is the y values, and we always go in increasing order, which would be the bottom to the top. So if I put my pencil on the lowest point of this graph, this dip down here, I can see my y value is -2. Now this graph goes all the way up, and the highest point we can see is this point here, and its y value is 3. So my range is going to be everything from -2 to 3. Again, the end points, the low and the high, are included. They're filled in circles, so I'm going to use brackets on these boundaries. So I'm going to use bracket, -2, comma 3, bracket. Part I, find the x-intercepts. We remember x-intercepts are the x values where that graph hits the x-axis, intersects the x-axis, touches the x-axis, crosses through, any of those. So we're going to look on our x-axis here, and we can see this graph hits it 1, 2, 3 times. So my x-intercepts are going to be here where the x is 0, here where the x is 4, and here where the x is 6. Now the problem will tell you how to write the intercepts. You can write them as ordered pairs or as just x values, so please pay attention to the instructions, especially in my math lab where they're very strict on the form, but I'm just as strict on quizzes and tests as well. So our x-intercepts as ordered pairs, we'd have 0, 0, 4, 0, and 6, 0. Again, or if we wrote them as just x values, that would be x equals 0, 4, and 6. Part J, find the y-intercept. So we know we're looking for where this graph intersects the y-axis. So here's our y-axis. We can see it intersects here. And what is the y value here? Since it's actually the origin, we know that y value is 0. So our y-intercept, written as an ordered pair, would be 0, 0. Or just written as a y value, y equals 0. Part K, how often does the line y equals -1 intersect the graph of f? So first we have to remember what the line of y equals -1 looks like. Well, we know when the graph is just a y equals, when the equation is just a y with no x in it, we know that's a horizontal line. So this is going to be a horizontal line down where the y value is -1. So if we go on my graph here, that would be approximately here. So I'm going to just approximate that line, y equals -1. And I can see it would hit the graph twice. It would hit it somewhere right around here and here. So my answer then, how often does it intersect? It intersects twice. Part L, how often does the line x equals 1 intersect the graph of f? So now we're reviewing, what does an x equals 1 graph look like? Well, remember when it's just an x value in the equation with no y, that's a vertical line. So we're going to go and draw a vertical line where that x is 1. So I'll just approximate it here. So this is our x equals 1. And we could see we'd hit our graph once. Part M, for what value of x does f of x equal 3? So now they're giving us a y value, f of x equals 3, y is 3. So we're going to go up on our graph where the y value is 3. So here's the 4 and the 2 would be halfway between here. So if I look across, I'd hit right here. Here is the only point where the y value is 3. And what is my x value there? It's 5. Part N, for what value of x does f of x equal -2? So again, they're giving us a y value. Y is -2. So I go on my graph here. Here's where the y would equal -2, anywhere along here. And we can see it hits it once here. The y value is equal to -2 right here. And what is the x value here? It's 2.